Your task in this section was to figure out in what order are the words 1, 2, 3, and 4 logged out when this log order function is ran. Well, let's log it out and see what happens. We get 1, 4, 3, and 2. At first, you might think that 1, 3, 4, and then 2 is logged out because of this 0 set timeout here. But that is not the case. We get 1, 4, then 3, and then 2. Why does this happen? If we have a 0 delay, doesn't it mean the same as having no set timeout at all? And the answer to this is no. Even though there is a 0 millisecond delay, the set timeout still affects how long it takes our statement to run. And this is because of something called the event loop in our browser. The event loop uses a queue in which all the events that happen in our event browsers are placed. These events can include click events, AJAX calls, callback functions, callbacks placed in a timeout or intervals, and etc. All of these events are placed into the event loop queue and then processed one at a time in the order at which they were placed in the queue. So this means that even though our third console log is wrapped in a set timeout that has no delay or a 0 millisecond delay, it is still pushed into the event queue because it is inside of a callback function. Let's see a visual explanation to understand what is happening under the hood exactly. So the event loop in the browser actually uses a combination of the stack and the queue. The stack or call stack holds the state of what the function is currently running. So JavaScript will run the current frame or function call in our stack and then remove it and move on to the next one. And the queue is where all of our events that happen in our event browser are placed, down here. So using our current example, it looks like this. We first add our first statement onto the stack, which logs out 1 to the console. And so we get 1 as our output. And then we are done running the statement, so we pop this off the stack. Next, we add our next statement onto the stack, which is a set timeout with a callback function in it. This means that we have to place this in the event queue for further processing. So we add the callback function onto the event queue, which starts a timer of 500 milliseconds. And then we pop our set timeout off the stack. Third, we put our third statement onto the stack. This also has a set timeout with a callback function in it. And so we have to place the callback function into our event queue for further processing as well. Then we pop our set timeout off the stack. And next, we push our fourth statement onto our stack. This statement logs out 4 onto our console. So we just get 4 as our output and pop this off the stack. Now we're not done yet. The event loop checks the event queue for any pending messages or events that are still processing. So the event loop checks the event queue down here and see that we have 2 events still processing. The callback function with the timer of 0 millisecond delay finishes faster. And so we pull this function off our queue and push it onto our stack for processing. This function logs out 3, onto our console, so we get 3 as our output. Then we pop this off the stack. And finally, our event loop checks our event queue for any pending events in the queue. We have one more event pending, which is the only one pending, so we pull this off our queue, push it onto our stack, and this function logs out 2 to the console, so we get 2 as our output, and pop this off the stack. And that's it. That is how we get our output for this answer. In a nutshell, this is how the event loop works in JavaScript. That's it for this lesson. See you in the next video.